Hello friends, in this session we will be discussing about waveform charts and the graphs. Waveform charts. The waveform chart is a special numerical indicator that displays one or more plots. The waveform chart is located on the controls palette and graphs subpalette. This is the typical figure of a waveform chart. Waveform chart can display single or multiple traces. Charts use three different modes to scroll data. Those are step chart, scope chart, or sweep chart. Default mode is a step chart. To change the mode, right-click the chart and select Advanced, then Update Mode from the shortcut menu and select Required Mode. A step chart shows the running data continuously, scrolling from left to right across the chart. A scope chart shows one item of data, such as a pulse or wave, scrolling partway across the chart from left to right. Here, this is the latest value. A sweep chart is similar to EKG display. A sweep works similar to the scope, except it shows the old data on the right and the new data on the left, separated by a vertical line. Here, writing a single plot chart, you can directly write a scalar output to the waveform chart as shown in the following block diagram. Here I am having a temperature control which is directly connected to the step chart, and can be placed inside a while loop. Wiring a multiple plot charts. Waveform charts can accommodate more than one plot. For this, you must bundle the data together using the bundle function, which is located in the functions palette and clusters subpalette. This one. The bundle function bundles or groups the output of three different VIs that acquire temperature for plotting on the waveform chart as shown here. Notice the change in the waveform chart terminal icon, this one. To add more plots, resize the bundle function to increase the number of input terminals. Means if you want to add one more plot, we just can resize this bundle function to accommodate that input. Graphs. A graph indicator is a 2D display of one or more data arrays called plots. LabVIEW features two types of graphs, XY graph and waveform graphs. The waveform graph indicator is available on the controls palette and graphs subpalette. The waveform graph plot only single valued functions with uniformly spaced points, such as acquired time varying waveforms. The waveform graph is ideal for plotting arrays of data in which the points are evenly distributed. Single plot waveform graphs. For basic single plot graphs, an array Y values can pass directly to the waveform graph. Here, at this point, all the values, 100 values are accumulated and they are passed directly to the waveform graph. This method assumes the initial x value and the delta x value are 0 and 1 respectively. You can bundle data consisting of initial x value and delta value and the data array to that graph. Here, as shown, we have taken the value x3 and delta x 0.5. Now this particular graph will start from 3 and the increments will be of 0.5. Now again see the graph icon which changes. The data can be passed to a multiple plot waveform graph by creating an array of data types used in the single plot example above. The bundle array function available on the functions array palette creates a 2D array from the 1D array input or creates a cluster array from the cluster inputs. Here, now see this again, this wire changes. Here initial x value is 0 and the delta x value is 1 for both the cases. If initial x value and delta x value for the each array is to be specified, then we have to use the bundle function as is shown here. The x parameters do not need to be same for both sets of data, they may be different. XY graph. The XY graph available on the controls palette and graph subpalette. It is a general purpose Cartesian graphing object ideal for plotting multi-valued functions such as circular shapes or waveforms with a varying time base. The bundle function available on the functions palette and cluster subpalette combines the x and y array into a cluster wired to the XY graph. Now the corresponding values of x and y, they are plotted. One is taken on the x-axis and the other is taken on the y-axis. Thanks.